Okay, thank you very much, Irene, and thank you all for coming out to listen to us. We've got a great panel here, and I'm not going to take too much of your time, but I'd really like to give you a little bit of background about what we're talking about. I took some very careful notes on my napkin here, and say logistics, supply chain, and feedstock. These are the things that we're going to be talking about, and logistics is something that is critical to all industries. And if, let's say you have a little oil field up in the upper Midwest, and you've got a great technology like hydraulic fracking to pull the oil out, and you're basically harvesting the oil, if you will. And when you get it out, you pump it into a storage tank. That's the first step in your logistics chain. And since we don't have a pipeline, then a train pulls up and you pump into a rail car, the train takes off, it transports the oil down to a connection with a pipeline, you put into another storage tank, and then off it goes eventually into the pipeline down to another storage tank next to a refinery somewhere else in the country. And basically we're talking about logistics and a supply chain ultimately leading to the production of, let's say, fuels and also products, and ultimately to a value proposition. I think that's one of the key things that all of these supply chains that we're going to be talking about today are bioeconomic supply chains, and we're going to have a really interesting time taking a look at that. Let's see if I can. So one of the things is, what is biomass and what are we talking about today? Biomass comes in a variety of forms, and we're really looking at renewable sources of carbon in the context of the bioeconomy. Certainly we have sugars that can also come from starch, from things like corn kernels, from sugarcane, from sweet sorghum, but we also have oils and lipids which come from oilseed crops and algae. But the focus of today's presentations are going to be on lignocellulosic biomass, or biomass containing cellulose and lignin, and these can come from a variety of sources, including crop residuals, like the residuals left over after you harvest corn, which we call corn stover, forest residuals. Let's say you have a forest operation, all the branches and treetops and bark that's left out there can also become part of that biomass chain. Dedicated energy crops. There'll be a number of presentations talking about specific crops that are grown for producing biomass for bioenergy and bio-based products. Now you're going to see throughout this, bio-based products and bioenergy go hand in hand, because you really can't make biofuel without also making bio-based products, just like you can't make petroleum-based gasoline without using the rest of the barrel of oil to make higher value products as far as that's concerned. And we also have plantation-grown trees, such as willow and poplar. Integrated supply chains are really critical. There's got to be feedback loops going from a conversion platform, a conversion technology, back down the supply chain to inform what's happening to the quality of the feedstock moving forward. You're going to get a very in-depth dive into that with some of the presentations. But biomass, as Meg said, is transformed into feedstock for biorefineries through feedstock logistics, and we're going to talk about that. Now, the challenge of feedstock logistics is every time you have a step in a logistics chain, you actually lose a little bit of carbon that you've taken out of the biomass, and you also increase the cost of moving that material through the supply chain, ultimately to conversion and on to distribution in markets. But the opportunity that we have that's being realized by the folks that are going to be presenting today is in the research and development, which has been working to optimize feedstock quality and to reduce cost at each step of the supply chain. A biomass supply chain looks something like this. You can actually have a harvest of a crop or plantation-grown forest biomass, or you can have collection of residuals, and it could even be something like municipal solid waste. After harvest and collection, you have to reduce the bulk density of the material to reduce the cost of transporting it. So there often is a densification step of one type or another. Then there's transportation. You have to move from the production side of the biomass to where it's going to be processed into fuels and products. Storage is another issue, and each type of biomass has their own storage nuance that really needs to be examined. And then once you move that out of storage, to get into the biorefinery, often you have to go through a pre-processing step to convert this biomass into feedstock. The feedstock is actually what is going to go into a biorefinery and be converted into product. And so in the pre-processing step, the end of that is the transfer into the biorefinery. And this is really a critical step in terms of making an economical and seamless integrated transition from biomass to feedstock to product and ultimately to a value proposition. I'm going to give you a couple of quick examples from some projects that the National Institute of Food and Agriculture, that I'm a national program leader for with USDA, has fielded. We've taken on an integrated approach to look at supply chains in regions across the country, and we have 7 very large projects that are doing that. But these regional projects are targeting the development of sustainable systems for the production of bioenergy and bio-based products. These are public-private partnerships that are often led by universities, but also include industrial partners, state partners, non-governmental organizations, and the like. Take a transdisciplinary whole systems approach, and to us, transdisciplinary means we're working with the folks that are going to be impacted by a new industrial footprint before that footprint ever reaches them. So it's really community outreach up front and have the communities help guide us. We're focused on feedstock development, production, and delivery. These are really the key steps in making an economical supply chain for the bioeconomy. And we integrate research, development, demonstration, education, workforce development, along with outreach to farmers and information transfer, technology transfer to producers, processors, and communities. We also overlay that with sustainability analysis, including economic, environmental, and social. And the focus of this is to understand risk and to develop a value proposition that will work for a particular regional supply chain and one that will ultimately attract investment. This is a quick map of the projects that we have in the field right now. You can see that there's a variety of woody biomass and herbaceous feedstocks that we're looking at. I'm going to give 3 very quick examples from this using the AHB, the NERA, and the SUBI projects to give you an illustration of biomass feedstock supply chains. The Southeastern Bioproducts Initiative, led by Louisiana State University Ag Center, is working with energy cane and sweet sorghum. And this is a typical supply chain for an herbaceous crop. These are perennials. They're planted, they grow very quickly, and then they're harvested, moved into a delivery system, and then ultimately go to a pre-processing site or depot where they can either be shunted into storage or actually processed into sugars, syrups, and cellulose, and ultimately those go into the biorefinery as the feedstock that they need. So this is emblematic of an herbaceous crop, dedicated energy crop supply chain. But we also have purpose-grown trees. And here up in the Pacific Northwest, the Advanced Hardwood Biofuels Northwest project, led by the University of Washington, is really looking at plantation-grown poplar, which actually can be grown and mowed down just like you would harvest let's say corn with a combine. This is what they've done here is modified a forage harvester and are able to use this modified equipment to actually mow down the poplar trees, which grow about 20 feet a year. And when they mow them down, they come back up and resprout, and they keep this process going. So it's a very prolific and sustainable way to do things. So here's another example using woody biomass moving forward. But one of the things that's really critical to all of these projects is reaching some type of value proposition, because just the fuels themselves are not going to be enough of an economic outcome to drive this forward. So in this particular project, they're looking at a whole suite of other industrial chemicals to make that bridge from poplar trees to drop-in fuels such as alternative jet fuel. They also are looking at environmental co-products, which are really critical in terms of This is a wastewater treatment facility that's where the poplar is being used to actually clean up a point source pollution source. And so this is another way that they can create value through these types of projects. And the final example I'm going to show you, this is the Northwest Advanced Renewables Alliance led by Washington State University. They're working with companies like Weyerhaeuser, Gevo, who's their jet fuel producer. And this is the material they start with. If you think about this, they're working with Weyerhaeuser. These piles of slash are left out in the field. After 3 years, they're burned. So there's a huge amount of carbon that's going up in the air. They also has a lot of mill waste, and really moving forward on that. And here's their supply chain, moving from forest residues through the transportation cycle, a sulfide pretreatment, enzymatic hydrolysis, and ultimately production of jet fuel. And just this last November, Alaska Airlines successfully flew from the first commercial demonstration flight using woody biomass as a source for the jet fuel from Seattle to Washington, D.C. And the Gevo was the one that produced the jet fuel. This particular project has, again, a lot of different things go into creating the value. You can see the jet fuel itself is only about 1/3 of the value package. And so that's my introduction right now, and I'm going to move on to introduce Sam Jackson.